Hello everyone, let's get started with the next topic for this training, which is on row and column store. So basically what is a row store? So let's go to the next slide. So basically a row store is, say for example, this particular table. You have this table where you have different fields like customer is one field, country is another field, product is another field, amount is another field. So in this particular table, this first row, second row, third row. So data is organized in rows format. So if your data is organized in a row format, it is called as a row-based storage. Okay. If your data is organized in a column format, say for example, you have one column, first column is a customer which has 100, 100, 200, 300. Like that, you have hundreds of different uh, fields which is stored in the synchronous manner. So basically, when do we use a column store or when do we use a row store? Row store is mainly used when you need to restructure the complete row. Okay, so say for example, if you want to report on all the columns, then the row store is most suitable. Okay, because restructuring the complete row is one of the most expensive column store operation. And when to go for a column store? See, if you want to fill the table with huge amount of data that should be aggregated and analyzed, then a column store is more suitable. So this is one thumb rule that can be used, that is, in case if the column is pretty small column, it has just few rows, say for example system tables, configuration table, metadata. So this type of tables are the ideal candidate for the row store table. Okay, then when to go for a column store table? Column store table is basically if the size of the table is pretty huge, it has huge amount of data and which can be aggregated, which need to be aggregated, need to be analyzed. So this type of requirement is an ideal candidate for a column based storage. Okay, so let me go to the next slide, which talks about the different recommendations of when we should go for a row store table, when we should go for column store table. But high level, as I said, that if your table size is pretty small, it has very small number of rows and small amount of data, then it's ideal candidate to go for a row store, because restructuring the complete row is one of the most expensive column store operation. So when to go for a column store? So thumb rule is, in case if you have huge amount of data that should be aggregated and analyzed, then go for a column store. That is the most ideal way to go for. Okay, so let's go in details about when it is recommended to go for a column store table, when it is recommended to go for a row store table. So here we can see in the slide that is telling about when to go for a row store table. So the table has a small number of rows, such as configuration table, just we saw. It's basically the some of the ERP tables which is storing just the configuration information. Then the application needs to process only a single record at a time. Okay, so that is another criteria for going for row store. Next is if the application needs to access the complete record. Okay, so in that case it is advisable to go for a row store table. Then say for example your aggregation and fast searching is not required, because as it is the column is, as it is the size is pretty small. Okay, so that is one area where to go for row store. Then row store is used for SAP HANA database metadata, for application servers internal data such as ABAP server, system tables, configuration data. All this is used. It uses a row store table. Okay, let's get into when to go for a column store table. Column stores are executed on a single column or a few columns only. Okay, say if you have multiple cores, then these can run in parallel. So parallelization is one of the key features of a column store. Okay, the table is searched based on the value of few columns. Table has large number of columns. table has large number of rows and column operations are required, for example, aggregate, scan, and so on. The majority of columns contain only a few distinct values. It is compared to the number of rows, resulting in higher compression rate. Okay, here you can see that uh, how the optimization of memory can take place in a row or column store, and what the key benefits of a column store is massive parallel processing. Okay, here you can see the first is the way the row store is organized. Here you can see the first row is 1A 10 pound, then B $35, C 2 pound, D 40 a pound, E $12. So in this manner or in this order the row store will be organized. Okay, so for columnar storage, it will be organized by columns A, B, C, D, E, then 10, 35, 2, 40, 12, then pound, dollar, pound, pound, dollar. So in this manner, it will be organized in the memory. Okay, so conventional database stores records in rows. Storing data in column enables faster in-memory processing of operations such as aggregates. Then columnar layout supports sequential memory access. A simple aggregate can be processed one linear scan. Massive processing is possible in column store. Okay, let's go into the details of the different advantages. So one of the key advantages is parallelization. Parallelization is column-based storage makes it easy to execute operations in parallel using multiple processor cores. In column store, data is already vertically partitioned. That means operations on different columns can easily be processed in parallel. So that is one of the key benefit or key feature of in-memory computing as well as the column store. Okay, if multiple columns need to be searched or aggregated, each of these operations can be assigned in a different processor core. In addition, operations on one column can be parallelized by partitioning the column into multiple sections that are processed by different processor cores. Okay, so that is one key benefit. Okay, second main benefit is about the high performance for column operations. So operations on single columns such as searching or aggregates can be implemented as loops over an array stored in contiguous memory locations. Such an operation has high spatial locality and can be efficiently executed in the CPU cache. Okay, the next main benefit is the higher data compression rates. So columnar data storage allows highly efficient compression, especially if the column is sorted. If it is sorted, it will give more compression. Okay, this is especially promising for SAP business applications as they have many columns containing only a few distinct values compared to number of rows. For example, country codes or status codes as well as foreign keys. This high degree of redundancy allows for effective compression of column data. In row-based storage, successive memory locations contain data of different columns, so compression methods such as run length coding cannot be used. In column store, a compression factor of 10 can be achieved compared to traditional row-oriented database systems. Okay, so that was one key benefit is compression, then elimination of additional indexes. So additional indexes, because as it is everything is there in memory, and storing data is in column works like having inbuilt index for each column. So the column scanning speed of the in-memory column store and the compression mechanism, especially the dictionary compression, already allow read operations with very high performance. Okay, so that's all in the advantages for this. Here you can see that how the data can be split and can access individual cores of CPU, thereby enabling parallelism and giving a better performance for the data. Okay, so column store features, here it is showing that how the main data is organized, how the delta is organized, how the read and write operations are taken care, so that we give a better performance in storing the data in the column format. So let's see in the studio. Let me connect to the studio right now. Okay, so let's go to the studio. Okay, here you can see the difference between the row store and the column store. Here you can see this particular table is a row store table. You, you can just see that these are in the row format. See the icon, it is in the row format. See all other icons which are in column format, they are vertical. Okay, so let's see how it looks like. Here you can see this is the name of the table. It's in this schema and the table type is row based table. Okay, the same thing, say for example, let's come to this particular table which is column store table. Here you can see that type of table is a column table. Okay, so that's all I wanted to cover in this particular training session. Thanks everyone. Thanks for joining and have a nice day. Bye bye.